Multi-protocol label switching, exactly correct. Label. Labels are nothing but tagging system. Tags. See, OSPF also we tag sometime. BGP also we tag. We tag EAGRP also. But that's an old method, tagging. And then based on the tag, if a tag is found, do this. If not, do that. Those things we used to do earlier, tagging. Now we don't have tagging. BGP attributes are full of tags, you know, full of tags. Some are well-known tags, some are discriminatory. Attributes are tags. MPLS is going to have a label, not just for filtering traffic or something like that. This is going to determine the path selection. The label that we are going to assign to a packet will be the reason for router choosing a path. Usually, the destination IP address is what selects the path. See, when we have routers, let me call it as 1, 2, 3, 4, 5, 6. In order to reach this 5.5.5.5 from 1.1.1.1, to reach 1111 from 1111 to 5555, the packet source IP address is 1.1.1.1, destination is 5.5.5. The packet goes to router 2. Router 2 sends it to router 3. Router 3 send it to R5 via E0. Why it is not taking path via E1 and E2? Why it's not taking path via E1 or E2? Because the destination of the packet is in this direction via E0. This is the direction via which the destination is available. The routing table of R3 shows R5 as a gateway, not R4 or R6. So it is the destination IP address that decides the direction of the traffic flow. Now, router 3 needs to know the destination IP address of the packet. For that, router 3, what it needs to do is, it needs to decapsulate layer 1, layer 2, then it will see layer 3. In layer 3 header, you are not simply having one IP address, you have a lot of fields in layer 3. You got fragment field, you got TTL, QoS, InstOS field, type of service field, version, option field, checksum field, protocol field, and also you will have source address field, destination address. All these fields will be there in a layer 3 header. In layer 3 header, this is not the only two fields. We have a lot of fields in which a tiny portion with this 32-bit IP address and 32-bit destination IP address. Please try to understand, I'm trying to teach you the need of MPLS. For that, I'm explaining what is the problem when we don't have MPLS. When we don't have MPLS, every router to know where I should send, it needs to scan complete layer 3 header to know one small information called destination IP address. In order to know this one thing, each router needs to scan a big layer of layer 3 header. So there are a lot of fields in this layer 3 header. After reading this field, this field, this field, this field, all fields, it uses only this destination IP address. It uses only the destination IP address info from the field and decides to go this way. Let me show you the layer 3 header. There are many fields in this IPv4 header, but this is the only field that you really need in order to route the packet. But how can you read only this? Without reading these fields, you need to scan completely. Only then you can know that one small destination. It is not possible for you to go directly to this portion. Not possible. You have to read the complete layer 3 header. To avoid this, MPLS is introduced. How MPLS can solve this problem? MPLS adds a label to the packet. MPLS adds a label to the packet. So, using that label, routers will know the destination. Please understand. Every router uses label now so that when a packet comes with a label, that label will tell what destination the packet belongs to. So the routers need not to scan this layer 3 header. The routers will not look into layer 3 header. For every single packet, it used to do layer 3 lookup, layer 3 header scanning. But from now on, as soon as you enable MPLS, from now on, it will not read any of this field. It won't even look into this layer 3 fields, none of this field. It will see MPLS header, which is very simple, not this big. MPLS header is not this big. This is too big, too much. This is very big. MPLS header will be only this much compared to IPv4 header. This is MPLS header. In this, you will have a label. And this is totally 32-bit size. Please understand. The size of MPLS header itself is only 32-bit. Earlier, in order to know the 32-bit IP address, we used to scan thousands of bits and bytes. I should say bytes of information. See, this optional field and all, sometimes we'll have too much. This optional field will have a lot of things. So you need to scan a big amount of information. But now just 32-bit. You scan 32-bit, you will know the destination. In that 32-bit, 20-bit is MPLS label. 3-bit, we call it as COS bit or traffic engineering bit, TE bit, or experimental bit. It's just 3-bit, not more. So out of 32, 23 is over. Next, there is one bit which is called as bottom of stack. Bottom of stack. Bottom, not upper, under, bottom. Bottom of stack. What is stack? Keeping one above the other. So if you go to Godown, where they store things in Godown, they'll keep one box over the other box. There'll be one washing machine, there'll be another washing machine on top of it. It's a Godown, right? A paint box. They keep one above the other. Stack. Sometime when you have VPNs, you will have more than one MPLS layer. Even in IPv4, when you don't have MPLS, when you have IPv4, whenever you got VPN, you will have multiple layers of layer 3 header. Multiple layers of layer 3 header. See, in one packet, you will definitely need at least one layer of layer 3 header. But if you are doing VPN, you will have more than one layer of MPLS, sorry, one layer of IPv4 header. Likewise, when you got VPN with MPLS, you will get more than one, you will have more than one MPLS layer. Instead of IP layer, you will have MPLS layer. More than one MPLS layer. Then which MPLS layer is the last layer? That is shown using this bit, bottom of a stack. Listen, when I have more than one MPLS layer, The upper layer of MPLS will have 0 in this field. Bottom of a stack field will be 0. See, as it says, bottom of a stack. So the below layer, the final MPLS layer, is what called as is what going to have this bit on. On means there is no more MPLS header to read. This is the last header. Right. So out of 32 bit, you got 20 bit for label, 3 bit for traffic engineering or class of service, which is nothing but layer 2 QoS, or experimental bit, meaning you can use it for either, you can also use it for some other purpose. That's why it is experimental bit. And then one bit is for informing the router that this is the last MPLS layer, bottom of a stack layer. And in layer 3 header, you see there's something called time to leave. Time to leave is one of the default loop prevention mechanism, loop free mechanism. Time to leave. Have you seen packet sent from a Linux computer? When you try pinging from Linux, the TTL will be only 64. I'm going to ping from Windows computer now. See, when I ping from Windows computer, ping www.yahoo.com. See, the TTL is the time to leave is very small number. It's like 54. Every operating system has got different TTL value. Can you someone try pinging from your computer and tell me what TTL you see? Same ping yahoo.com and see what TTL you get. What is the TTL you see? Ping www.yahoo.com. Ping now. Do you see any other number other than 54? Anyone see any other number other than 54? Definitely you will be seeing. Ping www.yahoo.com. What is the TTL you get? Okay, thank you. All right, so you're getting 50 and 52. From my location, it is 54 hops away, meaning I'm far away from your place. So you are a little near to Yahoo. I'm a little far from Yahoo. Okay, Shivam has also sent a picture for us. What about others? Anyhow, what I want to show you here is the time to leave is always there when you ping. And you want that time to leave to be seen when I ping over MPLS network. So because I enable MPLS, I don't want to compromise with the quality. TTL is good. It shows how many hops away the destination is. It also prevents loop. If there is a loop, the packet will disappear after 255 hops. So it's a loop prevention mechanism. The packet cannot leave after 255. 255 is the max. When the packet is sent out, some operating system will send with 64. Some operating system will send with 128. Cisco routers will send with 255. So when a packet is sent with 255, it cannot go more than 255 hops. So when there is a loop, the loop is controlled by vanishing those loop creating packet. The packet get vanished after 55 hops. So the TTL is important. TTL is good. The TTL from layer 3 header is copied here. And how many bit is needed for TTL? 8 bit. So the TTL that is there in layer 3 is also seen in MPLS layer. So only these two things are needed from the IP header. Number one, destination address, not the source address, and the time to leave. Only these two is what you need to route the packet to a destination. You don't need to really process the other field. So we use MPLS so that we can know our destination using label, which is knowing this alone, and then TTL from this 8-bit. Because MPLS have got these two information, it is enough for a router to decide the direction, to decide the path. So router needs only this. When R3 receives the packet, it needs to know only the destination and the TTL to decrement. For example, when I ping from here, it is 255. When it goes here, it is 254. What I'm talking about? TTL, time to leave. And when it goes here, it is 253. Now R3 will decrement it and send 252 here. So the time to leave, which is there in IPv4 to prevent loop, is also now available in MPLS layer. As a result, MPLS can also prevent loop. At the same time, MPLS processes the packet much faster than IPv4 routing. Because MPLS header is only 32-bit, just 32-bit. To know the destination and the TTL, you only scan 32-bit of MPLS header. But if you see in IPv4, just the IP address itself is 32-bit. Source IP is another 32-bit. So this itself is like 64-bit. Source and destination itself is 64-bit. Think about the other fields. So definitely, the routing is going to be faster when we have MPLS. because we are not reading this big header, we are just reading the small 32-bit header. Now, if a router needs to read MPLS header and ignore layer 3 header, this is how it has to be arranged. You see, this is layer 3 header, IP header. MPLS sits right below layer 3 header. After only comes layer 2 and then layer 1. We all know OSI layer. Layer 2 is the place where the MAC address, the checksum values and so on. And then layer 3 is the place where you have source and destination IP address. Now, after reading layer 3, after reading layer 2, before going to layer 3 comes MPLS. And in this itself, you will know using labels. Using the label and the TTL, the router will be able to decide the direction of the path. So it need not to read this big header. We have layer 3 header on every packet. We are not throwing it out. We do have layer 3 header on each packet that comes in to a router. Router reads this first layer 1 and then layer 2, and then it reads the MPLS header and stops. Router, there is no need for router to read layer 3 because the destination is already known. TTL is already known from this MPLS header. These two are already known. So there is no need for reading the layer 3 header. Router simply forwards it using the labels. So MPLS, as the word says, multi-protocol label switching. See, that's the meaning of label switching. Based on the label, which is found before layer 3 header, immediately after layer 2 header, the packets are forwarded, the packets are switched. What is that MP? Multi-protocol. MPLS is not a routing protocol. It depends on the routing table. It depends on the routes provided in the routing table. The routes are determined by various protocols. MPLS can work with all those protocols. You can work with OSPF provided route, EIGRP provided route, EIGRP provided, BGP provided routes, ISIS provided routes. So multi-protocol label switching MPLS can determine the path using label, no doubt in it, but still they depend on routing table. You need to understand this. This is two different things that we are talking about. Routing table is on the router. Layer 3 header is on each packet that comes inside the router. Understand? Routing table is in the router. That layer 3 lookup, that routing table lookup we still have. Do we have routing table lookup? Of course, yes. Ceph is there, which is built using routing table. So we do Ceph lookup always. In which layer is Ceph? Do anyone know where is Ceph? Ceph stands for Cisco Express Forwarding. Ceph contains the routing information. In another word, Ceph is a routing table in a layer 2 of the router. Repeating again, Ceph is a layer 3 information in a layer 2 level of the router. What is the advantage? Because we have Ceph, we no need to go through the routing table all the time. Because we have Ceph, there is no need for reading the routing table. So Ceph is already there on the router. Routers are not reading the layer 3 routing table every time. But routers were reading the incoming packets layer 3 header. Incoming packets layer 3 header needs to be read to know the destination. For that destination, routers will use a Ceph table, which is in layer 2, and it used to forward the packet. But now, after MPLS, on every single packet header, we got a new layer called MPLS. So you don't need to read the layer 3 header. So you please try to understand. Ceph is a change done on a router. MPLS is a change done on a packet. Both are contributing in less process utilization, less time taken to route the packet. Understand? Before MPLS, we have Ceph. Whether MPLS is there or not in Cisco routers, Ceph is on by default. Not only on Cisco, on every device. Even in Juniper, we have fib table, which is same like Ceph, fib, forwarding information base. In Huawei also we have fib table. Now what this table contain? This table contain the routing table. Usually routing table is in layer 3 header. Sorry, in layer 3 of the router. But the Ceph, what it does is it downloads the layer 3 information in a layer 2 level, in a buffer in layer 2 level, so that packets need not to be processed by layer 3 engine. Just by layer 2 processing, like as you are reading the MAC address, you will also know the exit interface and the gateway IP address. So we were trying to avoid reading the big routing table with the help of Ceph, and the routing became faster. Now after MPLS, it became much more faster. Why? When we don't have MPLS, we read the layer 3 header of every incoming packet. And then we use the Ceph table to go out via a port, via an interface. But now As the packet comes in, we just read the 32-bit header, and we use that label, compare the label with the Ceph table label, and the match is found, and we use the Ceph entry to give us the exit interface and the gateway. I don't know how much you can visualize whatever I'm saying now, but I'm going to show you these things. So far, what I have explained to you is the advantage of MPLS and where MPLS works. MPLS stands for multi-protocol label switching. So it is a label switching protocol. It can provide a label. Using a label, the packet switching will be far faster. MP stands for multi-protocol. It is because this MPLS can support any layer 2, layer 3 protocols. Any layer 2, layer 3 protocols. So you may have a Ethernet, or you may have a frame relay, whatever, in layer 2. It's okay. PPP, HTLC, it's okay. In layer 3, you may have OSPF, EIGRP, ISIS, PGP. And it doesn't matter. MPLS can provide label for all routes in the routing table. Some routes may be given by OSPF, some routes may be given by EIGRP. That's why multi-protocol, the name multi-protocol. I'm going to quickly show you a demo, and then we will go further deep into it later. Right, this is our topology. I need to add show IP interface brief. Do I have? I don't have a loopback interface. Let me add it here. Interface loopback 0, IP address 3.3.3.3. I would like to check what routing protocol we currently run. I remember it was EIGRP. Show IP protocol. Yes, it is EIGRP. I can see the distance as 90, and the EIGRP number is 100. So let me go under router EIGRP. Show run section router. Right, so I'm going to say another network router EIGRP 100. Network 3 is my loopback. I'm advertising. Okay, so now if I ping from here to 4.4.4.4, the ping goes. Let me ping it from the source loopback 0. The ping goes. Okay, fine. This is purely IP, not MPLS. For example, if you go to router 1, and check show IP Ceph 4.4.4.4/32. You can see, please understand, I told you Ceph is like a routing table. But the routing table in layer 2, in a layer 2 level, usually what you will get in routing table, you will get the next stop address, where to send the packet, and via which interface to send the packet, you see. On router 1, it says these are all the information we usually see on routing table. But here we see it in the layer 2 table called Ceph. This is Ceph table. It says in order to go to folder 4, router 1 says this one. You need to send it via G6/0, this interface, and the gateway should be 10.12.0.2. You see, 10.12 subnet. So this is what you need after looking into routing table. This is what you expect from a routing table. But we don't do route lookup anymore because Ceph is already running on every router, giving you the route information in a layer 2 level. This is what layer 2 Ceph table that has got routing entries, route information. Because we have Ceph, routers are already not looking into layer 3 engines table called rib table. Because the same information that is found in the rib table is now available in layer 2 Ceph table. So Ceph makes the routing faster. You don't need to read the layer 3 table, routing table. But in order to know that packet needs to go to 444, I need to read layer 3 header of the incoming packet. I need to read the layer 3 header of the incoming packet. We are talking about two different layer 3. Ceph takes care of layer 3 in router. MPLS takes care of layer 3 header in a incoming packet. As the packet arrives into R1, router will just forward it to router 2. Router 1 will know that I need to forward it to router 2 by reading the label that comes inside the packet. I'll be enabling MPLS shortly. After enabling, I'll show you the same output. What you will have is a label like 18 or something here. Right now you don't have any labels. But after you enable MPLS, the labels are generated and assigned for each routes in the routing table. For each routes in the Ceph table. Routing table is what's seen in Ceph in a layer 2 level. Label will be assigned to the Ceph table. Not only that, every incoming packet will be attached with MPLS header. Please understand. Right now, when I sniff the packet, you won't see MPLS header. You will not see MPLS header. But after I enable MPLS, you will have a new header called MPLS. Alright. Remember, when I ping now, not from this, from router 3. When I ping now, you don't see ICMP packet. Do you see any MPLS header in it? ICMP you see, and layer 3 header you see. This is layer 3 header. Look at this. Listen. We are trying to avoid reading all these fields. You see how many fields in layer 3. Internet protocol is a layer 3 header. You have version, you have header length, you got means DSCP means type of packet, QoS, total length, identification flag. Inside the flag you got more, and then offset, time to leave. You see, time to leave, protocol, and then comes the source and destination. So to know the destination and the TTL, we need to read all this. But after I enable MPLS, you see how it looks. I'll do the same thing after I enable MPLS. First, let us enable MPLS. Enabling MPLS is very simple. You see, like this. MPLS IP. Interface serial 6/0. MPLS IP. That's it. You need to do it in the global mode as well as on the interfaces. And now on R1, MPLS IP. Interface serial 6/0. MPLS IP interface /6/1. MPLS IP. Now MPLS neighbor has come. We'll talk about these things in detail later. LDP, label distribution protocol. MPLS IP interface 6/0. MPLS IP interface serial 6/1. MPLS IP. One more router. Interface serial 6/0. MPLS IP. The global mode MPLS IP. Done. So we have MPLS. Now we will see the difference. Please pay attention on R1. Earlier when I was showing Ceph table, it was not showing any label, but now you see the label. LABEL. Label 18. Not only that, when I now ping, earlier I was pinging this. And Wireshark, let me bring it behind. Now let me ping again. You see, when I show you the ICMP packet now, let me ping again. Let us trace the route instead of pinging. Why the ping is not showing MPLS? Hold on, let me troubleshoot. There may be some trouble. What? No, that is a hello packet. No, that's not. Show MPLS forwarding table. I'm trying to ping for there is an outgoing label. So definitely there is an MPLS. Let me again ping. I should pick 3 to 4. Yeah, look at this. See? ICMP, layer 3, and before layer 2. See, in layer 2, what do you see? MAC address, source and destination MAC address. But this is serial interface still see. But you see MPLS here. This is what I mean. See the 20-bit, you can't run C, you'll see 20-bit. Label 17. To write 17, there are 20-bit allocated. And here, see this 5th bit from the right, it is 1, which means 16. 16 plus 1 is 17. So we got the 17. Experimental bit is 0, bottom of a stack is 1, TTL is 55. So earlier we used to read the layer 3 header to know the destination, but now you see only the label. I showed you the label on R1. Now let me show you the R1's MPLS forwarding table. Show MPLS forwarding table. Look at this, the bytes that was switched using label. Let me try to ping again and show you the bytes will increase. You see, it is increased. This proves that the packets are not IP routed, it is label switched. Packet going from 3333 to 4444 is label switched. Alright, so I have just given you an introduction. Why and what MPLS is. This is the best explanation one can give for MPLS. Why MPLS and what it does. When you enable MPLS, IP routing is going to be label switched. Instead of reading the layer 3 header, the MPLS header is going to provide the destination and the TTL. So instead of reading the layer 3 header, we simply read the 32-bit value to determine the destination. And router already have got CEF. To that CEF, show IP CEF 4.4.4.4. To that CEF, a label is assigned. So when a packet comes with the label 18, CEF will say, okay, I know your label number 18 means you want to go to 4444. So please go to this gateway, this interface, period, finish. See how quickly the router can decide the path. When a packet comes with the label 18, CEF table says, oh, label 18. Label 18, I know the meaning of label 18. It is 4.4.4.4. Then you have to go to router 2 and you need to go out on this interface. So there is no need for layer 3 header scanning on every incoming packet. There is no need for layer 3 route lookup. Simple label switching. Any question?